Morning to all of you, and thank you for having me present our findings on the Digital Innovation Project to you here at Hospital Royce. As you know, this project was carried out as a solution to ongoing issues with the organization of medical administrative data and the hospital's vision to move towards a future of being more paperless, predictive, and efficient. Our interdisciplinary team, composed of Ria and Adrian from the Digital Innovation Team, or DIT, and myself and Gabriel from the Digital Optimization and Predictive Analytics Team, also known as DOPAT, was tasked with evaluating two major streams: the effectiveness of a new patient portal interface and the predictive value of collected patient data for improving planning and services. Now we move to part 1, which is evaluating the new patient portal. We tracked nearly 300,000 patient visits to two iterations of our hospital's portal over a 3-week period in January, an old one and a new one. Participants were either placed in a control group, viewing the old version, or a treatment group, viewing the new version. We identified the process by first cleansing the dataset to eliminate improperly classified groupings and redundant entries. All that was left was a clean image of conversion behavior, namely, whether a user converted upon reaching the site. Starting out, over the course of approximately 3 weeks, the Digital Innovations team accumulated a dataset with these variables shown. We used we used the user ID to locate duplicates in the data and remove them, and the groups to divide the data into two sections, those that landed on the old page and those that landed on the new page, seeing whether or not these individuals converted to the new website the DIT is working on for the hospital. The DIT member Ria noticed that there is some overlap for the control group, which should be solely the old website, and the treatment group, which should be solely the new website. So she cleaned up the data, removing these inconsistencies, as well as the aforementioned duplicates. She compiled a different graph to help depict relationships the DIT saw. First to note that using the timestamps provided, the DIT saw that there was the biggest change of user engagement right at the beginning and end, which is just fascinating. But the results steadily showed that only 1,500 people converted out of 12,000 in all of these timestamps. Next up was a basic distribution, which shows that out of 290,584 observations, only 34,761 of them signed up to the website. But specifically though, what is the outcome by group? It was practically the same distribution between the two groups, the control and treatment. Both had roughly the same amount of not converted and converted. And finally, we saw that within the control and treatment, we saw a slightly higher number of individuals that converted from the old page than the new page. The DIT at Hospital Royce worked on these different websites to sign up their patients to an online portal, since the hospital was going towards a digital, paperless system to help manage medical data. The team was optimistic and felt that the new version could lead to a 20% conversion rate, hoping to show this so they can use the remaining budget to help patch up the new website. The hospital board has assigned the DIT to see if this is the best move. Since prior expectations and assumptions are required, DIT member Ria decided to implement A/B testing to update these prior beliefs using the data. Ria used three different priors, the first one being this informed prior that has been observed in the past, B220 distribution, where it displays the belief of a 5% conversion rate. But the rates are higher than this, shown after taking all the data samples into effect. This shows that the conversion rate for the control group is higher than the treatment, but both not reaching 20%. Similarly, with a flat prior like this, it was able to get the same conclusion as the other prior, with the data being only 0.001% off. Even an unconventional prior like this, despite not having a big enough sample size to bring it all the way down to around 12%, still shows that the older website is a better fit. No matter which prior we use, the result always yielded higher conversion rates for the old websites. So it seems like that the budget should definitely not be put into this new website. Let us continue the observations. The IT member Adrian continued to see what the actual probability of the new page having a higher conversion rate than the old page is. First, he wanted to see how many sample sizes were needed to make any classical prior beliefs unnecessary, which will be needed to help find out the probability discussed. To find this, he used the B220 and B11 mentioned before, but as well as a clueless prior B.5.5 and a suspicious prior B130, and used these to find out when the means of these were close enough. You can see on these graphs that at 100 and 200 the posteriors get closer, but not close enough. At 679, the means of these four posteriors are within 0.5% of each other. But is that close enough? Adrian decided to get within 0.1% of each other, which occurred at a sample size of 3,398. The dashed line represents the posterior mean calculated from the B220 distribution, which is a 11.87% conversion rate for the new website. He did the same with the old website, getting a 12.05% conversion rate, leading to these graphs. These posteriors confirm a bit differently from the new website. Just settling is a slightly higher conversion rate. Using the 3,398 sample size, we find out that only 6.83% of the time the new website yields a higher conversion rate. Definitely, with a probability that low, do not switch the budget over to the new website. We, at the Digital Innovation team, suggest that the budget be used elsewhere, like encouraging signups in other ways, like in-person signups at the hospitals or easier user onboarding to reduce confusion. Definitely keep the old website. Let us flash forward a couple months after we created this patient portal. We now have a lot of data to use from this. This is where the DOPAT comes in with their insightful innovations. We now move to the third part of our project, which is predictive analytics using patient data. Moving on to the second half of our project, me and Gabriel designed a shiny new web application to forecast the length of stay of a patient based on several factors such as age, gender, and diagnosis, starting with cases of pneumonia. We first observed many discrete variables on the pneumonia patients, some of which include the mean, the median, and the quartiles, to better know the population that is afflicted by this disease. Then, with the use of such data, we've created a program which, with Bayesian models using the BRMS package, the app gives internal staff an instant, probability-based estimate of how long a patient will be staying. It can aid with resource planning, scheduling, and patient expectations improvements. So, for example, the app might tell us that a 55-year-old male with pneumonia is 30% likely to stay exactly 7 days. From the exploratory data analysis, the median stay for pneumonia is 7 days for male and female, in concordance with what the app predicted. Using the above collected data, we were able to create a shiny new website which, with its easy-to-use interface, can help doctors rapidly screen patients. Here is a preview. We enter the patient's name, the purpose of their visit, the gender, their age, and then we have the probability of it staying, the upon enter length of stay. After exploring the data, most of the patients are released within 10 days, and the prediction tool is thus of first-class importance for frontline planning. Demographic breakdowns confirmed that most of the pneumonia patients are aged between 50 and 55, which corresponds to the higher vulnerability of this age group. This indicates the true worth of digital data collection. As soon as the portal system gets used more rationally, we are able to make patient-specific, real-time predictions and materially improve planning and transparency. The tests we did to test our models found it explains about 55% of the difference in lengths of stay between patients, meaning a significant amount of improvement is still possible. As requested by the organization, we found that around 9.5% of patients stay for less than 2 days, meaning immediate day-to-day response is less of a concern over medium-term stays. Here are the final recommendations to the board. Based on everything we've heard, our company strongly recommends not expending the last of innovation budget on finishing developing the new portal version. Rather, we suggest spend it on user adoption efforts, reminders, emails and texts, improved onboarding, and improved promotion at clinics to encourage use of the current portal. Make improvements to the current portal since it slightly underperforms the new one and would be made progressively more usable. Thirdly, conduct further user research to learn what the new layout is missing before we make a decision to relaunch. Fourth, what we actually get to investigate is what we do with what we learn, and our length of stay predictor is merely the beginning. We should invest more in data collection to better help predict multiple factors that affect a patient's taking into the hospital. I thank you for your time and we'd be happy to respond to questions or discuss any part of the analysis in greater detail.